Strange things are happening in physics. It seems that physicists can't agree what's up with the expansion of the universe. Last year, a group claimed that the expansion of the universe does not, as we thought, speed up. That'd mean that the 2011 Nobel Prize in Physics was awarded in error. The Nobel Prize winners have now pushed back, but their rebuttal was also rebutted, and it's somewhat of a mess, really. But here's the brief summary. The universe is currently expanding. This part everyone agrees on. It expands simply because it contains matter and energy. However, in the 1990s, observations of supernovae seem to show something more. The universe doesn't just expand, the expansion is getting faster. Normal matter and energy does not do it. This is why physicists had to introduce energy with negative pressure, which is called dark energy, and not small amounts of it. 3/4 of the energy in the universe would have to be dark energy to fit the observations. The physicists who made the discovery were awarded a Nobel Prize in Physics in 2011. This Nobel Prize has been controversial for several reasons. One reason is that at the time many thought it was awarded prematurely. The evidence was not particularly strong back then. And that's true, but then again, the statistical significance has much improved since then, and the results seems to have held up. Or maybe it's just confirmation bias. Another reason is that the results partly looked convincing because the discovery was made by two different groups. However, if you do as much as read the author lists or the acknowledgements of the papers, it's obvious that the two groups were in contact with each other and shared results. These were clearly not independent analyses. This doesn't mean the results are wrong, but it's a way that biases can enter. Then last year, a completely different group looked at the supernovae data again, and they said there's a serious systematic mistake in both of the data analyses. You see, the way that one usually infers the accelerated expansion is to look at how supernovae look different depending on how far away they are. And since light moves, well, with the speed of light, the more distant the supernovae, the further back in time they happened. Looking at supernovae at different distances then tells you how the expansion of the universe has changed. The paper from last year then said, actually, the different appearances of the supernovae have nothing to do with the accelerated expansion. It's just that the further away the supernovae are, the younger the galaxies where the supernovae happened on average. And the age of the galaxy influences how the supernovae look. They redid the analysis and found that if one properly removes the effect from the age of the galaxy, the expansion of the universe no longer accelerates and dark energy is unnecessary. Bold, because unnecessary is not a word physicists usually apply to invisible things that explain everything. The news is now that a group which includes two of the original Nobel Prize winners say that the argument fails. They say that the new dark energy paper overestimated how much the age of the galaxy affects the supernova, and that whatever's left is accounted for by standard corrections. The bottom line is, they say the expansion of the universe is still speeding up. The university put out a bombastic press release that was widely picked up. According to the press release, lead author Dr. Phil Wiseman said, "The previous and well-accepted measurements were in fact fine, and our current understanding of the fate of the universe remains robust. Thankfully, we have averted this crisis, but the mystery about why the universe is still accelerating in size remains." The press release does not mention that this rebuttal was rebutted already in March by the authors of the original paper, who will defend their own analysis. At the same time, another paper was published by a third group, which redid the analysis using a different dataset of supernovae and found again that the acceleration is not there. This did not get a press release because that'd have made the Nobel Prize winners very unhappy. This isn't a joke. It's almost certainly what happened. There's a lot of infighting in departments about whose research will be publicly mentioned, and scientists who question the status quo are usually on the losing end. What are we to make of this? These aren't calculations you can check with a pen on a paper, so I can't tell you whose analysis is wrong or right, but I want to offer a general comment about the existence of this discussion. Obviously, the result depends on what you assume happens in the environment of the supernovae and how that enters the observations. This in return depends on how you think galaxies form and develop, which in return depends on our model for the universe. We know that these galaxy formation models are difficult to get right. They have loads of parameters to twiddle that'll give you whatever you want, and still they somehow manage to screw up the predictions for the earliest galaxies. My takeaway here is therefore that the data is simply insufficient to make a strong case one way or another. Galactic environments are not well understood enough, not today, and they certainly were not in the 1990s. So those papers all get a 5 out of 10 on my bullshit meter. But thankfully, the crisis was averted by the people whose Nobel Prize depended on averting it, always reassuring when the universe checks with the committee first. That there's a link between quantum physics and consciousness is an idea that dates back to the very early days of quantum physics a century ago. Most physicists today don't believe this link exists, and I understand the reservation. Then again, it's true that we don't actually know how the human brain creates conscious experience, so it's possible that quantum effects do play a role. Interestingly, we've recently seen new evidence supporting this idea, and no, it's not microtubules. Let's have a look. This idea goes back to physicist Matthew Fisher. In 2015, he proposed that the brain might use nuclear spins for quantum information processing. A nuclear spin is a quantum property of an atomic nucleus different from the electron spin. Concretely, Fisher thinks the spin relevant for consciousness is that of phosphorus-31. In the human body, some phosphorus appears in clusters called Posner molecules. These are interesting because they can protect the nuclear spins from the noisy biological environment. This means they could maintain their quantum properties, which is usually difficult in warm, wet, and messy environments like living tissue. This is the major issue with all these ideas that consciousness has something to do with quantum effects, that you need a way to explain why the quantum effects can be present in the first place. Roger Penrose and Stuart Hameroff say the microtubules do it. Fisher has this idea that it's a nuclear spin of these molecule groups. That, I have to admit, is a much cleaner way to encode quantum behavior. And in contrast to Penrose and Hameroff, he also has an idea for what's it got to do with consciousness. Fisher says that if two of these molecules carry entangled spins and later break apart in different places, they could release calcium ions in a correlated way. Calcium is important for signaling between neurons. So in principle, quantum correlations could influence neural activity. In principle, okay, but what about reality? Well, there have been a few new papers about this recently. In one paper, a group of scientists did a calculation for how long these phosphate molecules can retain quantum properties in the brain. Fisher himself estimated about 3 weeks, which seems somewhat ridiculous. A different group later corrected this to half an hour. The new calculation now says something in the range of a few hundred seconds, which is still fairly long. So this is not proof that there is a link between quantum effects and brain activity in general or consciousness in particular, but that maybe the idea is not as crazy as we once thought. In another paper, a group of scientists found that chemical reactions of this phosphate molecule with lithium isotopes depend on the nuclear spin. The relevance of this is not directly about brain signaling, but it lends credibility to the idea that the nuclear spin plays a role, probably because it interacts with the electron spin. And then there is a third paper whose authors conjecture that these phosphate molecules are the reason why psychedelic drugs act the way they do, which would basically be a direct link to consciousness. They have no direct evidence for this, but they argue that the drugs generate the right conditions for these particular molecule clusters to form. What are we to make of this? Okay, let me be honest. I think this is 100% bullshit. The problem is, I can't tell you why. I just look at these papers and think it sounds like bullshit. And then I think, this is not a very scientific reaction, is it? So I try to be open-minded and tell you about it. But well, this is what I think. It's bullshit. There is also the issue that so far no one's actually established that these particular molecules are present in the human brain to begin with. This isn't as easy to find out as you'd think. We know that they exist in human bones, but in the brain they'd be produced temporarily to take part in some signaling processes. So you can't figure out whether they were present from, slicing up people's brains after they've died. Also, it kind of raises the questions why my bones aren't conscious. So, is the origin of consciousness in some quantum processes? Probably not in this simple sense. But is the brain doing chemistry we still don't fully understand? Absolutely. And if phosphorus turns out to be important, I apologize in advance to everyone who thought the soul would be made of something more poetic. Thanks for watching. See you tomorrow.